fun. Yeah, fun it is. So yeah, no issues like in general.
Just a question about the online submission. I couldn't find where to submit it on Blackboard. Is there like an assignment Dropbox or?
Okay. It should be.
There is a Dropbox for assignment 2, but not for assignment 1.
Okay. Okay. I'll create that then.
Okay.
If it's, I think assignment 1 I gave you the paper copy. So I believe I haven't put that in the system. So the electronic copy is more for archival of record keeping kind of for next year's students, because we lost most of our earlier year's work because we switched from one platform to another platform, and in the meantime they messed up with my earlier course materials. Anyway, yeah, okay, I'll do that. I'll do that, so you can just give us and now we don't have half of the class today in this class because they have conference. So what I'm doing, I would just probably should let everyone know I'm doing the video of the class. So in case they can't make a makeup class, I probably put it in the YouTube or some way of giving that. Otherwise, I will take a makeup class, but this is my backup plan. So just for your I think you should know, like we are recording conversation, and feel free to talk though. Like I'm not saying like, but I'm just making sure like nobody have any objection. Do you have any objection? No? Okay. Thank you very much. Okay. So what we will be doing today is mainly talking about data, like in transportation planning. In transportation planning, we make a lot of different kinds of decisions. Like we make a decision, for example, like from the first class probably you have heard, like a lot of different decision-making agencies, players. But we do tremendous amount of decision making, including policy, planning. Steve, can you take another seat if you don't mind? We have a video running.
Oh.
Sorry. So we make a lot of different kinds of decisions, and to be very clear, in most of the transportation department, like the Ministry of Transportation, or for the municipality, the public works department, they have the biggest budget. So it's a huge investment programming in a sense, and those decisions could be, for example, building a new highway or changing a highway design. It could be the policy, changing the law, like 1 meter rule, like you can't bike, you can't drive like within 1 meter of the bike riders. So it could be policy, it could be planning, it could be big construction, supply side and demand side. So in supply side, like I should probably clarify, maybe I did in the first class. Like whenever we are doing transportation planning decision, that could be a supply side decision or demand side decision. Supply side decision means like we provide new lane, additional lane, we provide new highway, new transit line, new buses, those kind of things. And demand side is we try to manage demand, like flexible office hour, working at home, or travel planning by employers. So there are demand side, like the demand management decision as well. And so, like in general, in 60s and 70s, most of the decisions that we made, or like the majority of like the kind of type of decision we were making was supply side decisions. So whenever there is a problem, we try to put something on the ground, so some sort of infrastructure. But recently, for sustainability, environmental issues, concerns, and as well as like the global warming and greenhouse gas reduction of to reduce these greenhouse gas emissions, we started doing more and more demand management. Like often we call like travel demand management, TDM programming. So this is that demand side. But there are tons of decisions we need to make. And to make those decisions, what we need is understanding our supply system like means infrastructure, traffic flow, like the infrastructure lane, those kind of things. Also demand pattern, traffic volume, those kind of things, or the destination, origin, like from where people are originating, those kind of things. So we need a lot of information to make those decisions, informed decision. So that's why in transportation there is a tremendous amount of effort or initiative, like in every transportation planning department or transportation engineering department, public works or ministry, they do a lot of data collection, a lot of different kinds of data collection. So I will be talking today those kind of data, like what are the traditional kind of data collection initiative people actually do on the ground in practice. We will not be talking about what we do in doing research, like the state-of-art approaches. We'll probably more talking about the traditional, like what's in general everybody does or need to do and why they do it, those kind of things. So we'll be talking about that. I will also show some emerging technologies, like what people have started, like making use of. And right now, actually, we are in a very good shape because of the cell phone or smartphone use, those kind of, I will talk about, and also sensing technology. The sensor technology has become quite like in terms of, it's not expensive anymore. Like GPS, it's not expensive anymore, $100 GPS unit. Sensors, you can get $100, those kind of things. So I will show those kind of things. So what the outline of the lecture is, first of all, I'll be talking about these traffic data collection, like which was like the traditionally people do in every department. We will be talking about AADT technologies, and we do some comparison of technologies. Then, so these are more supply-related data. So to do supply kind of decision making, we take traffic flow. We count traffic. We try to do these like estimation of speed, those kind of things. And then I will be talking about the demand side, travel behavior data. Sometimes in Montreal, for example, they call it origin destination survey. In Toronto, they call it Transportation Tomorrow Survey, TTS. Maybe you'll be hearing those words. So I will show some of those travel behavior data collection, and also we'll show how we can analyze, like how we can see the trends and what can we make sense of those kind of data and what kind of policy implications are. So that's the plan for today's lecture. So these are like the readings. I have already uploaded a couple of the articles, as well as in the textbook, Modeling Transport. I think it's available in the library. It's not our like a recommended textbook. I only suggest to read this particular section, Home Interview Travel Survey, page 75 to 83. It's available in the library, and probably you borrowed my one, right? So probably like you can also get it from me, like a copy of it if you want to. So these are the readings, but most of the stuff like there I will be discussing briefly in this lecture. So my first question to you: why do we collect traffic data? Traffic data.
To understand real-time conditions, like what's actually happening.
To understand real-time conditions, what's happening.
Maybe to help alleviate some congestion.
To help alleviate some congestion, to take some measures, newer measures.
To inform policy.
To inform policy. Okay, so like we got probably the entire picture. But can you specify, like these are the broader, like yes, these are the things we need to do. But what really in practice we can do? Like in practice, like when we know, like we know there is a congestion condition, what things we can do? What kind of decision we can make? What kind of change we can make?
Design changes.
Design changes, like okay, design changes. What else? Design of the road, the geometric design of the road. We can change that. We can add lanes. Like I'm giving some examples just to have some flows of ideas.
Attempt to change driver behavior.
attempt to change driver behavior, of course, like we can divert them from one lane to another, those kind of things. Yeah, for the traffic, because we are talking now traffic, like the supply side of it. What else?
You see if there's a need to implement new transit.
Yes, so if there is a congestion is a higher level, maybe transit, so that we can reduce the number of single vehicle occupancy people and number of cars, so we can do that. What else we can do? We can do some HOV lane demarcation. For example, HOV means high occupancy vehicle lanes, like diamond sign. If you see, like in many areas, in Halifax, it's not quite yet common, but in many big cities, like the high occupancy vehicle lane, we can do that. And there is a new trend also, like what they call hot lane, high occupancy toll road. It's becoming very popular from like last 2-3 years, I would say, in the United States. Like, so what does that mean is if you have multiple people in your car, you can go with that lane, but if you don't, you pay. And the technology is helping us to determine who other people are, actually like one or two, or it could be also proof of payment kind of arrangement. Like the way, like for example, I don't know whether you know that, like in the commuter transit in Toronto, like you don't need to nobody actually check ticket for the GO Transit. Like it's a connecting Hamilton, Toronto, Oshawa, Toronto. Nobody check. It's a proof of payment. But they randomly check, and if you are not like with the ticket, then you get a very, very high penalty. So proof of payment can also work for our licenses. This is also proof of payment. Like nobody, like you don't need to every time show you have a license whenever you are entering into a highway or arterial road. So hot lane are using in different ways. In Singapore, like I saw, like they are using technologies to determine every time. In California and other areas, these are more, I would say, proof of payment, like those hot lanes. So to make these kind of specific changes in the roadways, the supply side mainly, it's not very much demand side, like we don't reduce demand, but for this supply side, we need to collect a lot of traffic data, right? Now, one of the most common data that you'll be hearing whenever you will probably be working in a traffic department or transportation unit or any consulting firm is average annual daily traffic. So what does it mean is we count how many cars are passing through one particular segment of the lane on a specific time. So yeah, and then we try to average annual daily traffic. For the bridge, it's important. Like for example, in our bridge, we do a lot, and our bridges are aging. Like if you can really understand, like the infrastructure in North America in many ways are aging. So we need, and the structure of the bridge, like it's a very old bridge, so it cannot like sustain a certain amount of the load to be operational. So, and they need continuous maintenance, so they need actually this kind of AADT to understand how much load the bridge is experiencing. And so this is one example, but we do a lot of annual daily traffic count. And if so AADT is average calculated traffic over a year, the number of vehicles passing a point in a given counting section each day, usually expressed in vehicle per day. So that's what we mean. Now, so this is one of the, as I was telling, one of the important piece, particularly for the like the transportation engineers, like they still like rely on this piece of information for planning for a new road construction, for doing some roadway geometry changes, some congestion management, access management, pavement design, and many others. And so you will find a lot of application of this. So now, how we do it? So there are two ways. So in many areas, we have permanent automatic counting stations and technology in place. So we have permanent like those counting stations, so we can have 24/7, 7 days a week kind of a count for a particular road segment. But sometimes it could be costly, right? Like to have in many, we cannot put everywhere those kind of things. We then have sometimes seasonal, temporary counting, and then use some methodology to calculate annual average daily traffic, because that's the main thing that we do want to know. So in general, for the permanent, we do 15-minute count or hourly count intervals, like in many cases. So not all permanent automatic doesn't do like 24/7. Sometimes a sample as well in the peak hour 15 minutes, a couple of times in the off peak 15 minutes, midday, and also a PM peak. They does that. So that's how we calculate. So it's easy to calculate AADT from a permanent data collection stations. It's really easy. In Toronto, in many places, like they do those kind of permanent automatic traffic recordings, use those kind of permanent recordings, recording. But there are this short-term recording, seasonal count. So they do certain cordon count, we call, like some different specific areas. They put for a short time some sort of they use technology that they do in urban areas, rural areas. So they sample the segments, to just get an understanding of what's happening in the key bottleneck areas, as well as in relatively the low flow, free flow kind of segments. They do that to do that. So, but it's hard to calculate with these kind of seasonal counting the AADT, like the annual daily traffic, because you have your sample is in different times, different seasons, so you have to have some sort of a methodology of doing it in a structured way, so that at the end you can calculate, you can show those AADT, and that could be useful for you. You can compare, you can make big decisions on that. In Halifax, in general, these kind of the semi-short-term traffic counts are being used for a long time, and they're not still very good at estimating, have a methodology to get some sort of very clear picture of how traffics are flowing in different sections, and that actually hinder, in my opinion, a lot of traffic planning decisions. So that's why this is probably one of the reasons, if you guys know about this Bears Lake controversy, the Bears Road widening project, it didn't have much evidence to talk with the community, whether it's really a congested area, what time, how. So there was no, I would say, the evidence-based arguments. That's why it falls apart. So we don't know really, to be honest, except our experiential knowledge, who the people who drive, the people who are waiting there, they have some opinion about it. But until we have some sort of this kind of scientific evidence, it's really hard to do this kind of large project, big project. If it was a small change, that could not, that can be done without this kind of in-depth study. But for this kind of big decisions, because it has implication on people's lives, people have to relocated from that area, so we need more sophisticated ways of doing this kind of traffic counts. Another piece of information very useful for traffic planning or transportation planning is vehicle kilometer traveled, VKT. This is more for demand management. So VKT means how many kilometers you, for example, travel in a given year or a given day. So that we know what are the total kilometers traveled by vehicle, so we know what's the emission you are emitting in a year, and how much we can actually reduce in different ways, probably some supply side measures or some demand side measures. So this is also another important piece of information that we collect traditionally in practice all the time. If you have any question when I'm talking, please raise your hand.
How is VKT
Calculated.
calculated?
Okay, I'm just coming. Next slide is like, so VKT is like one important piece we need to do. One of the, so I told like one of the main reason also why we collect VKT is this air quality compliance. It's not like very like relevant for Canadian context yet, but in the United States, like they have this new EPA Act, Environmental Protection Agency Act, that requires like kind of a compliance for compliance of certain air quality standards. So we need to know whenever there is a new development, whenever there is a new construction, new neighborhood, new subdivision, something new that we are changing within the built environment, we need to know how many kilometers actually you are increasing or decreasing, and whether it's actually meeting the air quality standards. Because it seems like there are like simple ways of calculating those emission, just multiplying how many VKT, what kind of car you drive, and then you can get at least some estimate of those air quality. So it's becoming very, very important. Like last week when I was TRB, I would say, like one big stream was only how to comply with these new rules and how to collect this newer data. So the smartphone conversation actually came from there. Like, because it's hard to collect VKT, but like in various ways, but people are looking at it because it's a practical challenge for practitioners these days, because they have to comply with the law, but they don't have enough tools to do that. First, let's go to some traditional tools of doing how we collect VKT. We can do it automated reading. Like in general, when you are registering or re-registering your car, you should tell them how many kilometers that car was driven. So the more, like technically or theoretically speaking, all motor vehicle registered should have this information, like how many kilometers was driven by one single car. And at the end, we need the entire city's kind of like the VKT, and we can do average and other kinds of things. So it's possible by doing that. So this is one way of doing that. But in general, the practical point of view, sometimes people doesn't actually give what your odometer tells. We don't match, we don't try, we don't check, we don't those accuracy. So it's sometimes very challenging. I'll go back to show you one reading which I uploaded. Okay, yeah, the first one. Road traffic data collection methods and application. So you will find more discussion on this kind of data collection as well as emerging technology in this paper, which I have already uploaded in our course website. Second is from the traffic count. If we have a very good comprehensive traffic count, we can also calculate how many kilometers you are traveling. But it's a little bit complex because you need to strategically look at from origin neighborhoods, like how many cars are coming out, and destination neighborhood, destination employment center. So destination in transportation planning, we often like view it as an employment center. So we need to know in strategic location, and I would say a very comprehensive set of traffic count to estimate from that traffic count like the VKT. It's hard because we don't know individual costs, but it's possible. Like there are ways of doing that. One easier way, or effective, not easier, I would say effective way is driver survey. If we have a random driver survey, we can do that. We can easily calculate it, those kind of VKT. For example, the data that we have collected last semester by 2 of our students, like household survey, what we call, and we collected the entire day's kind of your activities by which mode, so we can easily calculate what is our VKT in Halifax. And it's a random sample. Then it's easy to just tell this is the replication of the entire population. Random means I should like use some sort of technique so that I just don't select you like based on like our convenience, but more based on like within this like some sort of draw, like the random draws as I can put it in layman's term. We can also do it from fuel consumption, like France, Austria, and Portugal does that quite often, and it's actually quite elaborately explained in the document that I said, like in the course website. So from the fuel sale, like in a given year, like we can actually track that, because sales tax, like we give fuel sales tax, so we can get that data, like from that we can calculate how many kilometers like 12 different kinds of vehicles are traveling. Of course, that's also sometimes could be challenging, because there are different mix of vehicles in different urban or rural areas. Like you can have a SUV, you can have a Honda Civic, so the difference is different. Like, so we need to make some statistical adjustment to do those kind of things. So in many times, in this point, I should tell that in many times transportation engineers use a lot of adjustment factors, like from other areas, from other studies, like, okay, maybe some proportion for the SUV, some proportion for the compact cars. So like they do these kind of things quite often, and in general these are very important indicators. So that's the data collection procedures. We also need other kinds of data. So these two are very basic. We need it. So the first kind of data. We also need speed from the traffic flow. We need vehicle type, as I was talking with you, right? We need occupancy, like whether it's a single occupant, 2-person, 3-person, so that whether we can encourage more carpooling or those kind of measures. So these are also other pieces of information that we collect, and it has a long range of transportation planning applications. We need to know these kind of things. So the type of technology that we are using in the practice for a long time in the various transportation planning department is, for example, for the volume or count, and for speed, for classification. Classification means vehicle classification, whether it's a compact, SUV, or those kind of things. And occupancy, presence means like whether it's available in the road sector in a given period of time. So inductive loops is one technology we use. Magnetic loop, pneumatic road tube. We also use active infrared, passive infrared, microwave radar, ultrasonic sensors, passive acoustics, video image processing, those kind of things. And you can see from this chart like what kind of like attributes or what kind of elements that we can gather from each type of these detection technologies. So among them, some of them there are two broad groups. We call intrusive sensor, and other group we call non-intrusive sensors. And I will come to that point, like what does it mean. So let's look at certain technologies, and you guys probably have seen already some of those things, like probably 2 months, I think in the fall, in November. Like if you are driving in Halifax, you might see like there are pipes in roads, like in various sections there are some sort of pipe, it is pneumatic tube. So we are still like in the ancient age in many ways, but like in various sections there were those kind of tubes, rubber tubes. It's kind of your garden hose like kind of thing. So they are actually counting. Even in our university avenue, there was one but they have done that in November, like for the city-wide. So those kind of tube. There are inductive tube. It's in Toronto. So if you look at if you are driving in Toronto roads or arterials, you probably seen some sort of a black diamond. You can't, like, if you don't really look closely, you might not have recognized it. But like look at the road, you'll see some diamond cuts. Like there's no sign, but you can see those kind of inductive loops. And this is very, very common. Very like the popular technology in most of the cities. We have inductive loops here as well in Halifax. but in almost all cities, yeah.
Where would they be though? Would it look like that? So I can't think of seeing any trend.
It's not clear actually in this picture. I think there are some, it should be something like diamond-shaped cut, just cut. You will not see anything else, just a cut of diamond shape. And it's on the surface, that's why it's intrusive. I'll come to that point, so intrusive. In general, we have a very few in Halifax. Very few in Halifax, so it probably will be hard to like get that on the side. But in Toronto, in every road, if you look at in every kind of a stop sign, like in general, we do these near intersection or in highways. In highways, you can all see like after every exit, like there is a row of diamonds, like on the, you can see. It's not like white diamonds, like the sign for the HOV, but if you really closely look at that, you can see. And I think that there are tons of YouTubes like on those kind of things. So please feel free to use those kind of smart technologies to do those things. And there are also these kind of infrared sensors, which are not intrusive. So intrusive are more on the surface. Non-intrusive is outside the roads. So that's what like we use for traffic data. There is also this video image processing. You might see this on the Windsor Junction in Halifax. On the bridge, there are these kind of two technologies, and they also do temporarily in a given year by MyoVision, the company. They does some like that seasonal traffic counting with this image processing. So, and for planners, what do we need to do? We don't need to build these kind of like technologies. What do you need to know? What are the advantages and disadvantages of what technology, and what should we buy? Like as a planner, you will be recommending in your department, we should be buying this, and we need to know this way we'll be collecting and processing those kind of things. And these kind of things actually comes with the processing tools, so it's more visualization at the end. So I was telling that there could be these intrusive versus non-intrusive sensors. So intrusive sensors are these inductive loops, pneumatic road tube, magnetometer, and other weigh-in-motion sensors. That's another probably technology you should know about. It's more for truck or freight transportation. So we need to know how much weight they are carrying, and it can be done like without like taking them in the sideways and weighting them. We can actually use this weighing sensor, and it's important for our aging infrastructure, particularly for the bridges, because most of our bridges in Canada or even in North America, I would say, like probably in their like last stages, so they are just maintaining, and maintenance are really, really costly. You can't imagine. In transportation planning or engineering, any office you go, you will see the biggest budget is not the new infrastructure. It's not like the new thing to reduce this or facilitate that. It's actually for maintaining what you have right now. It's really ironic in many ways. Like it's just maintenance of the current road. And we have harsh weather, we have salt, and those kind of things. So we need to really start. That's why these kind of monitoring systems are becoming much relevant and useful and required for transportation planning, because we need to know what to prioritize to reduce this kind of road safety issues. Like in Montreal, probably last year, you have seen a couple of like bridge actually like collapsed, like when you were driving or those kind of things, and this happening because of this aging infrastructure. And there are reasons why Barack Obama is like now trying to pitch on these infrastructure banking or infrastructure spending, because in US as well, like they're the biggest giant highway system that they have, which is probably envy of any kind of countries in the world, are aging. So they need to invest. Right now they should invest in this monitoring so that they know, because they cannot fix everything all at once, so they need to prioritize which one should be done first or at risk, those kind of things. As a planner, we will be using these data to understand where the traffic volumes are higher, where we should be doing this kind of maintenance, programming or new roads, or providing transit to reduce the vehicle use, those kind of things. So it's bigger than what we think, transportation planning. In general, we thought like, okay, maybe like doing those active transportation, some lane or those kind of walking, biking could solve many things, because but that are very small piece of the puzzle. The biggest piece, you have to admit, we are still gas-hungry community, right? We will be driving, no matter, like, still driving is probably 80%, 90%, or 70% of our mode choices. This is the reality. So we need to really look at those things, because that's the big money-hungry kind of a program. So we need to understand this kind of like the impact more aggressively. Now there are so those are weighing motion and non-intrusive, which is becoming a little bit more popular in these days, because you don't need to dig the roads. And it could disrupt, like particularly for big cities, it's really hard. If something is not working, then replacing, you have to close the lane, and closing a lane is nightmare. For example, even for our Bedford highway, like if we want to close one lane, it's a one-lane highway, right? So sometimes it's very hard, so people are now looking at these non-intrusive sensors, microwave radar, laser radar, passive infrared, and you can get this kind of description of all those things in this document that I mentioned. And there are some installation methods, so intrusive sensors, we just put it directly on the road surface, and these are more above ground, mounted in the sidelines, like I showed here. Like this is non-intrusive, so it's in the side of the roadways. And also, there are some advantages, some disadvantages of those different kinds of sensors. Advantageous, intrusive is well understood technology. People are using for last 30, 40 years in these in their departments. So sometimes it's really hard to introduce these non-intrusive technologies to them. But there are also other things. Like for the intrusive sensors, it's hard to sense those speed, occupancy. Because transportation problems are becoming more complex, we need to know more than just the count, right? How many cars are going, because that was the only fair piece of information for most of the transportation department for a long time. But we need now different kinds of information. So we need, so that non-intrusive have the ability to do those vehicle count, passage, and presence, and speed, and multi-lane coverage with one sensor, so you don't need a lot of sensors on the ground, and easy to add and modify detection zones, so replacement is easier. But disadvantages, these are expensive, and sometimes weather condition can affect those kind of things. So please go through these list. I have already uploaded these lecture slides as well. And these are the cost. Like the intrusive are less costly, so you can look at the lifetime capital cost and some operation and maintenance cost. And for planners, these are important to know, because we have to also look at the functions as well as we have to look at the budget when we'll be doing these kind of recommending these kind of technologies for different areas. In Toronto, like they do extensively this image of a video image processing. Like they have lots of cameras on the roadways, and and in the weather channel, if you can recall, you can see those like the videos. So those are actually automatically detected and processed. And it was done by, it has been done by University of Toronto Transportation Lab, and they are quite successful in that. So based on that, what we are doing in our lab, like new lab, upcoming lab, we'll be putting in Halifax these kind of wireless sensors. It's a very, very new technology coming from Berkeley lab. It's a kind of a magnetometer, but it takes just 10 minutes to put there. This is a very small piece. Probably next year I can show it in my class. We'll be getting that. So those will be on the roads, and there will be some access point which will directly collect data, so we don't need to interrupt anything. And that data will wirelessly transfer to our lab in downstairs, right beside the Tim Hortons. So we can do 24/7, at least 5 stations. That's my pilot project for now. If city want to expand it, probably we can do, but it will be a tremendous amount of data collection for a very first time for Halifax. Now, so these are all car-related data we are talking about, like the vehicle-related data, but we need many other kinds of information as well. Transit ridership, we need to know that by point, station by station. We need to know boarding, alighting numbers, like where you have a demand, so that we understand like the demand, how many lines, how many buses we need to put there. And we are doing those kind of collections too. In Halifax it's more manual, but I will show other practices on what they do. Dwell time is also important. Dwell time is how much time it takes to get inside the bus, and it has impact on your overall travel time. So when we are complaining like our transit travel time is not good, probably we are not having good dwell time as well, because that can like those stop. So we need to think about how to design our stop, one stop to another, because if we have more stop, like the more travel time it might require for the dwell time. But so we need to optimize, like we have to service, we have to offer the coverage to the neighborhood, as well as we need to offer minimum travel time required. Waiting time is also a big item, I would say, for transit usage. So we need to understand how much on average you need to wait in transit stop, those kind of things. And it's very important piece of information in these days. Nowadays also pedestrians count is becoming quite important. So lots of sensors, and sensors are very cheap in these days, less than $100. Like it's a very inexpensive, and I believe within next 1 or 2 years in all our smartphone we'll have these kinds of sensors. I believe, because I have seen couple of lab in different areas are right now exploring this kind of how we can actually sense just with our smartphone. So I think like it will not be just the official counting of different things. We will see maybe people are blogging on traffic flows, on those kind of things, because they have this ability to sense like how many they are going to count. And for many other, not only transportation, this pedestrian count is also important for business, marketing, and other kinds of things. Like if you look at Walmart, maybe you will see some security cameras, right? So sometimes it could be dual purpose. It may be also for counting how many people are actually entering to the store. And these kind of data also used for the marketing for various reasons. For example, studies shows that like people actually turn right in general, like when they enter into Walmart. So all the junk products that they need to sell quickly, they put in the right hand side. Because they have seen from the data that they analyze, that's how they sell best. So those kind of things like that. So the business decision, marketing decisions are also made by transportation planners. I know a couple of my friends actually working in this kind of supply chain, Walmart or Home Depot, kind of those, just to do these kind of analysis and to offer these kind of advices. And this is becoming a quite big area, because whenever there is a private sector like available, those things could be very exciting. And you can also see those smaller kind of items in the first shelves, like when you are paying your bill. Like there are items that you might just grab. So it just didn't happen by accident. It was actually by design. So, and by design, to do those kind of things, we need this kind of information, pedestrian counts. And trail count is becoming also a very important, like on the trail, like how to maintain that. Just recently, HRM actually put a RFP to do this trail count, and we are collaborating with CBCL. One of my former students, Bruce Mance, like Implant student, he's now handling that with CBCL. Now, for the transit, like which is important in my opinion very much, we do this kind of what we call APC system, Advanced passenger counter system. So we can put this kind of turtle mat on the door. You can see in most of the Vancouver and Toronto buses, like we can have infrared sensor coming out of this. We can see these different kinds of equipments putting in different places so that we can automatically have boarding counts. So those are the technology used. But traditionally we can also do this fare box, like how many fare we are getting, but sometimes it's very hard by stop to do that stop by stop. So what we have, in general, we do like in Halifax is manual count. So we put people on the buses and they collect the data. And probably 2 years ago in this transportation class, I used my students to go to Portland Hill bus and they counted those, like the entire route, and it was quite successful. But in general, students don't like it because it's very early in the morning to get the peak hour data. So I sent them probably at 6:30 to that Portland Hill station, but that's why I stopped it from next year. But it was, students enjoyed the experience of data collection, but just it was not feasible, and I thought, no, okay, that's probably we should focus more on the technology part of it. Probably if we get some equipments, we are hoping this year, from next year I will be designing some assignments which use technology to do this kind of thing instead of this manual counting. And the reason why I did my one, because my public transit course professor did that with me in Toronto, Bay Street. Like we studied like the whole day actually, and that Bay Street is the Canadian Wall Street in some ways. So on that bus we were running probably 6 runs. We counted 6 runs in the morning and evening hours, and it was quite exciting. I learned a lot, just how the behavior of the people, dwell time, waiting time. You can't really imagine in the high block or high frequency section how much frustrating it could be and how much problematic it could be for entrance from the subway system to the buses and those kind of things. So so my point here, that collecting data sometimes could be very, very important. Any question? Please raise your hand, because yeah, go ahead.
I'm just wondering, like, it looks like the technology is really efficient in collecting data. I'm just wondering, like, the sensors, for instance, does it have any health implications?
It's a very good question, very good question. In general, I will outright discard the idea at this moment, because before being very concerned about these sensors, probably we should start being concerned about our cell phone signals. No studies like that is probably more frequent. We don't know whether there is a health impact of these kind of signals just running everywhere. Everybody have probably phone right now, so we don't know. We don't know. In general, there is no reporting. There is no concern so far. But I do agree. Like all these signal processing, we don't know where we are at. Particularly, I am very concerned about these smartphones and the phones, like the daily use. But these are occasional, like ones. I would say it's probably not like at all much different, because we all are already using these kind of sensors at our home as well. Like that, we have sensor light, right? In your probably driveways, maybe you have lights, like someone when go, it just turns on. We use a lot of sensors. These kind of sensors, I would say, like when we are playing Wii, Xbox, we are using this kind of sensor. This came actually from gaming industries, and also these kind of your remote control. Right? So the technology is not very different. So these are like similar kind of like your video, TV remote, those kind of technologies. So that's in general, I would say, like the common kind of supply-related data. Supply means this vehicle, infrastructure, ridership, those kind of data. So this is in general like what we do in the supply side. Mainly we do in the supply side. Do you have any comment, questions so far? No? Okay, so these are